So, hello everyone. On behalf of Vanguard team, today I will present the first open source RISC-V SoC project in Vietnam. My name is Quynh Do-ngoc and my co-worker is Quynh Do-ngoc. We are from VLSI Technology Page. The presentation agenda will have two parts. The first part we will introduce about the VLSI Technology Page, and the second part we introduce about our project Vanguard open source project. We introduce about structure, roadmap, and status, and purpose and resource of our project. So we will go to the first part. Our member of my page is close member from the engineer and technical student. We use many channels to share the digital IC knowledge. The blog to share the knowledge and experience of the IC design, and the base content built by cooperating between the engineer and student. And VLSI Technology Page also share the hardware technology in Vietnam. This page content are presented in Vietnamese language to help the technical student and new engineer can easier to study the new techniques. The knowledge are sold from the basics to advanced. So we hope that more and more students interested in the IC design career is have to develop the human resource for this area, and more sharing from the experienced people, and more public discussion on the IC design. Our activity will be processed in 5 steps. The first, we discuss and select the topics. And the second, we establish a theme for each topic. And then we make a plan and investigate the selected topic, create some example and tutorial. And finally, we will publish the result as documents or video. We in order to discussion, we use flexible communication for chats, email, online meeting, or face-to-face. And face-to-face is a working meeting. After meeting, we will collect all the question, issue, and status of the project. The current content is focused on the design and verification, but we are investigating the back-end phase. In the first phase of we focus on the basic knowledge to have the final year student and new engineer can understand the interested career. We hope that a newbie can understand what is necessary knowledge, and they can focus on their knowledge. Currently, we are developing some SystemVerilog, SystemC, UVM environment for verification, and RTL code generation tool for generate the register table. User can put the Excel file, and the output will be the RTL code. We design some small IB with detailed document and basic simulation environment. Everyone can investigate and study by themselves. And you can access our GitHub repository by this link. In the second part, we will introduce our Vanguard open source project. It's called VZ. VZ block diagram is close 4 block domain. The first block domain will be the VZ CPU core, and the second block domain will be the memory bus, and the third domain will be the display bus, and the flow bit, low bandwidth peripheral bus will be the last domain. For the target feature, the system bus which is 32 bits and system bus protocol will be ASI4 and ABB4. And for the clock domain, the VG CPU core will be operated with the higher than 1.2 GHz, and memory bus will be 1 GHz, and display bus will be 800 MHz, and the low bit peripheral will be 200 MHz. Our system are divided into the five subsystems. The five subsystems will be grouped together. The VG CPU will be the one subdomain, and memory bus, display bus, low bandwidth peripheral bus, and configuration bus. For the detail of IB function, you can see in the table. About the VG CPU core, arbitrary architecture from the raw logic will be used in our system. The RV trail is highly configurable, single issue, single core, RV32i and RV64i. It supports user level ASI version 2.2 and release architecture version 2.10. For our VG SoC, the configurable interface will be changed, and the original socket only supports ASI line interface. So we add more interface to this configurable interface. Currently, the SoC can support ASI4 protocol. So why we choose this RISC-V for our SoC? The first thing, SoC is royalty-free industrial standards instruction set. So it's easy for everyone to access and use in their open project. The open source community will grow strongly like ISA become more and more popular. So in the hardware world, RISC-V role, I think, will be the same as the Linux OS in the software world. And the second reason, RISC-V is not only built on the FPGA, but also driven by the silicon, and some chips are commercial, such as Sci-Fi and Syntacor, etc. And the third reason, according to the RISC-V website, the performance of RISC-V chips are comparable to the ARM chip. Consistently, Sci-Fi UA series should competitive with the ARM Cortex-A72. And the last reason, this ISA also supports 32-bit instruction and 16-bit compressed instruction. They can use in many chips from the small embedded to the high-performance processor. So for the roadmap, in the first release, we only replace the CPU, bus system, and on-chip memory, and some trial IB from the FPGA library, and it is used on the FPGA. And the second release, we will build a full system includes on IBs. The IBs are designed by our member. And the third release, we developed some application on the SoC. For the RISC-V score development plan, in the first and the second version, the RISC-V CPU is open source core from a raw logic with the following modification. And the bus interface unit can change from the ASI interface to a ASB interface to ASI interface to improve the system performance. And unit test environment of the CPU core is also updated. Currently, the modification accomplished and verified with the set of instruction RV32 UI and RV32 SI from the RISC test. The RISC-V as a implement and execution are investigated in deeply currently. So we will prepare information for the third version. The RISC-V score will be improved, and architecture will be redesigned this score to build a super-scalar processor. For the status of our project, RISC-V CPU core modification and unit test are accomplished. And about the bus system design and basic verification of ABB bus are accomplished, and the full simulation of environment is being built. ASI bus is ongoing to design phase, and on-chip memory is accomplished, and some peripheral such as FPGA, GOR, and CAN are accomplished. Our purpose to build RISC-V CPU core, we will supply an open source SoC to study, research, and use in Vietnam. Everyone can modify and for fitting with their system requirement, and develop a RISC-V SoC on FPGA. We will release some demo of our SoC in the real application. For the most RISC-V community in Vietnam, everyone will have the space to share, discuss, and cooperate together. About resource, currently our group has a core team, 10 includes 10 engineers and 2 students, and some supporters work in the short term, less than 3 months. It's from 5 to 10 members. Advantage, currently, advantage of our group, many students and engineers have a need for academic research, and the knowledge of the RISC-V start to be popular in Vietnam, beginning from the university and institute. Participants will have the access right to the project knowledge and data soon. So our disadvantage, the activity of our group are not regular because our members are working on their company, so that they are only zoned in the free time. The working time cannot be strictly because membership is voluntary and cannot zone full time. And no member has a lost appearance in the back-end phase. So I am completed my presentation. Do you have any question for our presentation?
Thank you. Well, thank you.
Yes, thank you.
Okay. Our first question. Okay.
Yes.
Which application can your chip be target?
So Our chief target is a general purpose MCU. At first, we will develop SoC on the FPGA for researchers can use and study by themselves. And for this purpose, this system includes many memory controller and display protocol. And some application can deploy such as.
Okay. First question is, which application can your chip be target?
Can you hear me? Can you hear me? Yes. So our chief target is a general purpose MCU, and we will develop SoC on FPGA for researchers can use and study by themselves. And for this purpose, this system includes many memory controller and display protocol. Some applications can be deployed, such as video, audio processing, LCD panel controller, and etc.
Okay, thank you. Next question is, how many universities in Vietnam currently teach RISC-V?
Can you repeat again?
Okay. How many universities in Vietnam currently teach RISC-V?
Currently, we only focus on one chip.
はい。
だけど、つくばを入れないといけないし。
Okay, this session is the end. Mr. Kwan, thank you for your presentation.
Yes, thank you very much.